Hey, welcome back to this presentation as we examine commercial plans and particularly plumbing pages. My name is Thomas, and in this video we're going to look more specifically at the details that you'll find on plumbing pages. Details are drawings of a specific section of the piping that gives a lot more information than just a line showing where the pipe goes. And when it comes to a header or a water heater, water softener, things like that, a lot of times valves and controls are needed, and these details will specify exactly what is expected as we're installing these in commercial situations. Let's start with this detail. What do you see here? This is a water header. A water header is the main line coming in. It's going to have a series of valves and controls. And this one gives us quite a bit of information about what is expected on this main water line coming into the building. Let's start at the bottom. What do we see? Once again, these were taken from actual plans, and the pages weren't exactly flat when I took the pictures, so you see a little bit of wave to the floor and ceiling. Let's assume that that's all flat, straight, and it's not going to be all, ski-wampus like that. As we look at this detail, what do we see? From the very bottom, we see that where the water line comes through the floor, it should be sleeved to protect the water line from the concrete floor. Then we notice it's a 2-inch line coming in, and they expect us to install a ball valve specifically. This is a shutoff valve, but they want a ball valve. Above that, we are going to install a double check valve backflow preventer with ball valves and strainer. Now that could be purchased all as one big assembly, but this is a backflow preventer that they expect to be installed right in the main line. After that, there's going to be a T with a valve, 3/4 inch line, and a hose thread. This could be used as a drain down for the building. Above that, there's a union, a combination pressure reducing valve, and a strainer set to discharge at 60 psi. They're getting really specific as to even the pressure that's going to be going into the building. Downstream from the pressure reducing valve, or up above it as we follow the line towards the ceiling, there's a T with a pressure gauge indicating pressures from 0 to 100 psi, and there's a small valve next to that that can be used to turn on and off if the gauge needs to be replaced. Above all of that, we have a union. This makes it possible for us to remove that section, replace the pressure reducing valve, and then the 2-inch supply goes on into the building. Up at the top, at the ceiling, they want this to look nice. So we even have a ceiling escutcheon. We'll put a little chrome-plated escutcheon or something right as it goes through the ceiling so we don't have some gaping hole. Now as an exercise, we might take time to look this over and create an actual parts list. This is what you would need to do as a journeyman, as a project manager. You're going to have to go through this thing and detail out, here's exactly what I need. It would be like, hey, tomorrow or next week, we're going to build up this header. So I'm going to list out everything that's needed, all the valves, fittings, adapters, whatever's necessary. Send that over to my supplier and make sure I have those valves and fittings on site when it's time to install. Here's a water line that's coming into a building for a different plan. We can see the water coming from below the slab. And this one, they even require a thrust block down below. As we follow the line up into the building, we see that it's a 2.5-inch line. There needs to be a backflow preventer. And then we go through this branched series of pressure reducing valves. Notice the line sizes. Notice the details that are put into this. As we follow each of these through, we see a basic series of the same thing, right? There's going to be a valve. We find some Y strainers. This is to keep any debris from going through and clogging up the pressure reducing valves. Then we see the pressure reducing valve.
Please note that you are expected to set the pressure to exactly 57 psi on the pressure reducing valve.
And another shutoff valve. So we have a valve on both sides of these. These are service valves that we can shut down, and we don't have to drain the whole building. We can shut those valves, service, replace our pressure reducing valves, or clearing the Y strainers as needed, and then they connect and go on into the building. Now, why do you think there are so many pressure reducing valves on this main line? One should be able to do the job. That's what we saw in the last detail. Well, in this building, there's a redundancy of these valves. Notice the line sizes. It comes in 2.5, The bottom line coming through, that's going to be 2-inch. We see it over on the right side. Then there's another one that's 1.5 inch. It's the middle line. And then there's one on the top that's 2.5. That'd be full line size. When it's all over, it's feeding the building at 2.5 inch pipe, but it kind of has those separations. We'll go back to that question. Why are there so many? The redundancy is so that we never have to have downtime. If we need to shut off the water to the building to service one of these pressure reducing valves, if it needs to be replaced or has a problem.
Notice that the 2.5-inch line across the top is normally closed bypass valve, not intended for normal use. Also notice that the 1.5-inch line set is a low-flow PRV set for 60 psi outlet. The main feed to the building is a combination of the 2-inch line at the bottom and the 1.5-inch line above it. These are the sort of details you're going to want to pay attention to on the plan.
When we get a detail like this, once again, we're going to want to look at every single thing on there. We can come up with a parts list, find all of the fittings, all of the valves, all the connection pieces, all of the gauges and pressure valves. We see a gauge, we see a hose connection so we can drain things down. All of those fittings, parts, valves can be listed out and ordered by looking at this detail and taking the time to figure it out. All right, I've got one more for you here. This is a main line coming into a different building. It's going to start over on the lower right side. We see a cloud that says 3-inch cold water supply. There are more details if I were to follow that cloud in the triangle elsewhere on the plan. But for this detail, let's just look at what's going on here. The water comes in. We're going to have a valve there. That's going to be a full 3-inch size valve. Then our water supply to the building turns horizontal and goes through this header. Now there's a lot going on here. We see redundancy, but pay close attention to line size. It goes to a 4-inch line size along the bottom, and we have a 2-inch bypass line size above that. Now once again, that redundancy is a backup plan. If we have problem with the 4-inch, we can shut that down, service whatever we need to on this water header, and maintain some water flow through the 2-inch as we're making those repairs. Then we get the 4-inch full volume turned back on. Let's follow the 4-inch line across. We come and we find a gauge, a pressure gauge, 0 to 150. They want to know what is the incoming pressure. And then we have our series of pressure reducing valve. Let's just jump ahead downstream. We find another pressure gauge, 0 to 100. We want to know what's the outgoing pressure from that pressure reducing valve, or the pressure that we're feeding to the building. Now this way, when I set the pressure of my pressure reducing valve, I can see what's coming into it, I can see what's going out of it, and I know if it's functioning properly or not just by looking at the gauges. Back to that 4-inch line, past the pressure gauge, we see another shutoff valve, then a Y strainer. This is again so we can catch sediment and junk, and that can be flushed out. Notice how those are piped together, and that can be run to a floor drain. We see some reducers, some unions, our pressure reducing valve, and then another shutoff valve downstream from the pressure reducing valve. This gives us in this line the ability to shut it off and service without draining down the whole building. And we see the same thing on the 2-inch line above that on our bypass.
Oh, excuse me, allow me to interrupt again. I didn't want Plumber Tom to leave out any important details. If we turn the plan sideways like this, you can see the notes a little better. Please notice that the pressure reducing valve at the bottom of this header is set to 60 psi flow rate at 110 gallons per minute. However, the bypass valve is set to a pressure of 65 psi at a flow rate of 60 gallons per minute. The higher pressure is intended to allow more water through in a bypass situation.
And from there, a series of branches. There's a 2-inch cold water going straight into the building, a 2-inch cold water line running over to the softeners. There's a smaller 1-inch supply line that's going to go over to the non-potable mechanical. This is going to feed the boilers and other things. We also see branches with valves, and hose bibs so that we can drain the system down. Once again, as you look at this header diagram, you can go through and figure out an exact parts list, everything that you need, and then you can order that. Now, there's one thing on here that I notice that kind of makes me wonder. 3-inch water supply coming in. 3-inch line indicated downstream from the pressure reducing valve, but it goes to a 4-inch line. Now, I could just take that at face value and install it as is, and I'm fine. But the question I have is that 4-inch really necessary? Could it be a misprint or a mistake? If I have a question like that on a commercial plan, the best thing to do is do an RFI, request for information. I can send an email or a message to the engineer and say, hey, I noticed this on the plan. Is this exactly how you want it? Was this possibly a mistake? And then they can clarify. So keep in mind that mistakes do happen. I've seen them multiple times on commercial plans, and it's okay to ask. It's okay to wonder, and it's okay to RFI, request for information. Let's look at a different type of diagram. This is a water heater detail. Now, take a look at this. Try to wrap your head around this. There's a lot going on here, a lot of pipes. This is where, once again, maybe coloring it would help to differentiate different lines and what's happening where. Let's follow this through for a minute. We've got clearly 2 water heaters that have to be connected. And whenever they're connected like this, remember that you're going to want to pipe them in parallel. This means that from where they split and tee to go to both water heaters, you're going to want equal distance of pipes so that the water pushes evenly through both of these pipes. That's not how it's drawn on this plan. But if you do it according to what is drawn here, you're going to have water flowing through one water heater really well and not much on the other. The one's going to do all the work. So if we have them piped together like this in parallel, make sure that you have equal distance for everything feeding the cold from where it tees, and then everything coming back from the hot to where it comes back together.
A quick side note here, the opposite of parallel is piping water heaters in a series, where the water comes into one water heater and exits and enters the other water heater before it feeds the system. This puts all of the strain of heating water on one water heater, while the other is more of a retaining or warming heater. Not the best way to do it, but it does save money. So some plumbers will pipe it this way.
That said, let's follow these through. Start over here on the cold water supply. They come across, we have a valve, and this symbol is a check valve. We don't want anything back feeding. From there, there's a T that's going to separate, and it's going to go down into both of the water heaters. We follow these down. These are 2-inch lines. Each of these is going to have a shutoff valve and a union connecting the water towards the bottom of the water heater. Coming away from the water heater, we have the water being fed from the top. The water comes up. There's a thermometer on each of the water heaters indicating the outgoing temperature. That way we can look at it right away and know what we're delivering. Then there's going to be a union and a shutoff valve. So these have shutoff valves for both water heaters on both the hot and the cold. This makes it much more serviceable if we need to replace a water heater. We don't have to drain down the whole building. It specifically states that the hot water to the fixtures needs to be 130 degrees Fahrenheit. This is a big building. We're delivering higher temperature water, most likely to be mixed down at the fixtures where necessary, bringing it to 110 degrees for any of the lavatories using a mixing valve. But that's what's being delivered. Okay, what else do we see going on? Across the top here, there is a hot water recirculation line that's coming back in. We see a series of pipe and fittings. We've got a Y strainer, a flow setter, that's a control on the movement of the water through the recirc line, valves, unions, and a recirculation pump. There's a check valve so that water can't be feeding backwards into that recirculation line from the cold. And that line does connect into our cold side somewhere. As we look at design, probably better to have that connecting before the T that branches to both of the water heaters So once again, it's pushing evenly through both of them. A couple other things we'll notice here. There is a domestic expansion tank coming off to the side. This is going to be a commercial expansion tank, and it's going to be bigger. It's probably going to sit on the floor, be a couple feet tall, and it's going to pipe off of the cold side. We also see the gas lines coming in. Those are supplying gas to the water heaters. In this case, we have a higher pressure, so there's going to be a shutoff valve for each and a regulator for each. They call it a pressure reducing valve, but as we speak the language of gas piping, we call those regulators. But it does reduce the pressure, so there you go. Now we also see from each of these, they're high efficiency water heaters. There's going to be an air intake and exhaust. Each of those PVC lines are being run outside to bring air in and to get the exhaust out from these water heaters. Now, again, there's a lot going on in this page, but as you slow down, take it line by line, and see what's required, you can figure this out. You could make a parts list, you could get this all ordered, and this might take a couple days to build up, depending on what you're dealing with. If it's all copper, solder, yeah, it could take a few, but you can get this put together. Here we have another water heater detail. You can see this only has one tank. Notice there's a lot more written detail on this diagram, explaining exactly what they expect. Cold water's coming in from the right. We see a valve and an expansion tank off to the right side. Feeds the water heater from below. There's also at the top a cold water line that's going to mix across. This is for a hotel, so they may need to set that temperature higher to be able to produce more than they would want to deliver. But they have this mixing valve at the top that they can bring that back down to a safe temperature. The hot is going to come out the top on this water heater. This is going to be a high efficiency water heater, and they're expecting us to pipe a heat trap. So you can see this little series of elbows. This keeps hot water from flowing out of the water heater by the fact that just hot water rises. Generally, a little U-shaped trap like that's enough, and we don't see those as commonly on water heaters, but in this plan, they still expect us to do that. So we'll just do what's there, right? We have the gas supply line on the left side, and then we've got our combustion intake and exhaust happening on there. Underneath here, we see that they expect a platform 2x6s and 3/4 inch plywood for that to be raised up off the floor. It needs to be 3 inches wider than the water heater. We see they want a pan underneath there, 16 gauge secondary drain pan. This plan also details the earthquake straps and what's expected for those, that they need to be anchored into the wall, certain gauges and sizes. Once again, you can see that by examining this plan, I should be able to get a pretty detailed parts list, get my parts ordered, and get to work. Have a look at this diagram. Now we're looking at a water softener detail. They want 2 water softener tanks. They're being fed from the top. We've got the cold untreated water that's going to split and go to each of the softeners. And then the water is going to come back away from the softeners, treated, softened. There is a bypass valve in case there's a problem with the softeners. We can just let water go into the building, right on past those. Let me point out again, though, the importance of even distribution, parallel piping. Now, this is something that's more like street knowledge. They've drawn this showing the diagram of the pipes and the valves that would be in those lines. That does not mean that you have to do it exactly as it's drawn to look like this, but the lines would need to match in what they do, right? So you've got a T, you've got valves, you've got unions. But if I want water to flow evenly through both of these softeners, then once it tees and goes to the softeners, and when it comes back and tees together after the softeners, those pipes have to be completely equal in distance, all of them, uniform. Otherwise, it'll push through one and it won't push through the other. Water's lazy that way. Same thing with the water heater, right? So this gives me everything I need to know as far as the valves, the T's, the unions, the softeners themselves. They're expecting me to strap them to the wall. We've got the brine tank involved, all the pipes, but I'm left with the ability to make sure that I pipe it correctly, pipe it in parallel so that it's going to work. And this detail is going to serve me well as I'm making my parts list. All right, from here in this presentation, I'm going to go through a series of details. We're going to go a lot faster than we have on these last few where we really took time to examine them. Feel free to pause the video at any point if you want a better look at this or if you need more time to examine. But here's what we have. This detail shows us the sump, the pump, the different controls, the alarms, the pipes coming in, the pipes going out, the vents, and all of those details that I would need to make sure this is installed correctly. Here we have a floor drain with a trap primer connection. You can see the floor drain in the sloped floor. We see the trap primer coming from the primer. The pipe's going to feed into the standpipe above the trap so we can keep that wet. Now there are different types of primers that we can apply to add water and keep our traps wet. One of them would be like this. Here's a diagram of one that branches off the domestic cold. There's a valve. It comes to a trap primer valve. This is basically a leak creator. It drips water from the supply and it feeds it down into the floor drains. There's a manifold, so this could distribute to multiple floor drains within the floor. Now, obviously, this diagram's like showing it all together. Those floor drains are going to be spread out in different restroom areas. But this gives us enough detail to know how that little primer system should work. Here's a much better option, or at least simpler option, for a trap primer seal is just a trap guard. They're showing us we can put that insert down inside the floor drain and do away with all the water and pipe that we would normally put into a trap primer. Here's a detail for a condensate receiver or an indirect waste. This is where maybe we've got some furnaces or other mechanical that needs to dump water. And they're detailing that they want a Santee, they want a trap, they want a bell, they want this blocked up wood thing so that, it's up above the floor. And all of this to create the waste receptor. Now, once again, let me point out that not all details in these are accurate or correct. Look at this sanitary Y fitting. It's saying sanitary Y fitting is what they want. But according to code, that'd be a Santee, right? You don't put a Y in that situation. It should be a Santee to be properly vented. So occasionally we find things on plans where it's not quite right. And once again, it's okay to ask questions. You can say, this doesn't look right. Hey, I'd like to request some more information. Should it be like this or that? Ultimately, we do whatever the engineer says. Here's a detail for a wall cleanout. You've got your test tee. It's going to be plugged. They want it 9 inches from the floor. There's some detail on exactly what they want. A chrome cover with a screw on the outside. So that's what we would be expected to install. Here's a building that has a cleanout for a urinal, and the cleanout is above the Santee for the drain of the urinal. Now, not all urinals have this, and not all are required to have this. It's not even a code requirement, but it is a really good idea for a urinal. And this is coming from people who've built buildings over and over and know that urinals clog up with crystallized urine, and if you can ram it through from above, it might save you having to rip the thing off the wall over and over, and that's helpful. So they have that cleanout, that's how they expect it, and that's how we would install it. Here's a cutaway of a roof drain showing how it's going to interface with the roof seal, and that's how we'd be expected to hook that up. Here's a detail for the downspout or the scupper for an overflow roof drain. So we can see how they expect that to be installed on the outside of the building. Here's a detail for a water closet support. This is a carrier for a wall-hung toilet. They're giving us a few specifics on sizes, distances, things that they expect to have installed. We'll find on plumbing pages pipe hanger details. They'll show us clevis hangers and what they expect. They show on this one a rigid pipe insulation around the hanger. Here's another illustration of that. The rigid pipe insulation is going to keep that insulation from collapsing under the weight of the pipe. They use a rigid calcium silicate. It's detailed right here. And, most of the time this is pipe insulators taking care of this. But as plumbers, we should be aware because we're going to need to oversize our clevis hanger. It says right on the plan. Make sure your clevis hanger is big enough to fit the insulation. And you're going to need to make adjustments to the hanger rod so that that can be adjusted up or down as that insulation is being installed. So these are all important details for us as we're running the pipe and creating the hangers for those. Here's a detail for a building showing us the vent through the roof. They expect 12-inch minimum as we penetrate through the roof. And then, of course, they need a roof jack that can seal up to the roof. Now let's have a look at some other details that we don't find on the plumbing pages, but that we definitely should have in mind. These are back on the architectural pages. They're detailing out fixtures, fixture layout, and specifics for ADA accessible fixtures. So you can see here what's expected. If I'm installing urinals or sinks, this gives me the exact height of where things should be, whether it's the rim of the urinal, the handle of the flush on the urinal. We have the sink, the height of the sink, the maximum height of the faucet, the drain underneath, the clearances below the sink. All these things I have to have in mind all the way from the rough. I can't just come in the finish and be like, well, I'll hang the fixture where it needs to be at this point, because those rough connections have to match. Toilets are similar. You'll see here, this is A3.4. Once again, we're looking at architectural pages, and there's things that we don't really need. Like, I don't install the grab bars, but I definitely install the toilet, and I definitely have to meet those requirements for height, for distance from the walls, and all of that stuff. Here we have a drinking fountain detail showing how high it needs to be for handicap accessibility. Here's a typical base cabinet sink. This isn't even about ADA, but this is a detail from an architectural page that shows us how high the cabinet's going to be, where the sink's going to sit in that cabinet, and where the shelves are going to be in that cabinet. All of that's really useful information as I'm trying to figure out where to rough in my pipes. We have looked at a long series of details, plumbing details from plumbing and other pages. You can see how useful and important this information is for you if you're going to be taking on this job. You have to understand how everything goes together and make sure that that happens. If you don't, they can come to you and say, this was on the plan. This is exactly what you bid to do, and you have to do it. And you'll go back and you'll have to rework, which is expensive and frustrating. I mean, who likes to do that? I've shown you some details, but the details on any given plan may be different. The important thing is that you're going to go to the plumbing pages, look over the pipes, look over the pipe diagrams, look over the details, and make sure you understand everything that's involved, especially with the plumbing, so that you can get it right and you can have an excellent rough and an excellent finish. Join me in the next presentation where we're going to look into the mechanical pages of a commercial plan and examine what a plumber should know on those. I'll see you there.